from ULJ Institute of Engineering and Technology. Today we are going to discuss subject Mathematics-1 with the topic extreme values in the chapter partial derivatives. So let's start the topic extreme values. Let u equal to f of xy be a function of two continuous variables x and y will be maximum or minimum for small positive value the point at which function f of xy is either maximum or minimum is known as stationary points. The value of the function at the stationary points is known as extreme values, that is either maximum value or minimum value of the function f of x and y. So now the working rule for finding the extreme values, that is first step, solve del f by del x equal to 0 and del f by del y equal to 0. After solving these two equations, get the values of x and y. Step 2, that is obtain the values of r, that is del square f by del x square, s, del square f by del x del y, and t, that is del square f by del y square. And last step, that is step 3 here, and this is the most important step here. Number 1, if RT minus S square greater than 0 and R less than 0, then function is maximum. Number 2, if RT minus S square greater than 0 and R is greater than 0, then function is minimum. Number 3, if RT minus S square equal to 0, if RT minus S square less than 0, then neither maximum neither maximum nor minimum, and this point is known as a saddle point. Fourth rule, if RT minus S square is equal to 0, then no conclusion is there. Further investigation required. Okay, so students, these are the three main steps, or we can say the working rule for finding the extreme values. So let's apply this rule for solving the example. Let's start our example 1, that is discuss the maxima and minima of the function x square plus y square plus 6x plus 12. So let's start the solution here. As our given function f of xy is equal to x square plus y square plus 6x plus 12, and as per the rule of the step 1, we have to find first del f by del x. So for the extreme values, del f by del x equal to 0. Now the derivative of f with respect to x, that is 2x plus 6 equal to 0. So if I get 2 common, I have x plus 3 equal to 0. So x is equal to minus. And similarly, the derivative of f with respect to y equal to 0. So the derivative of y is 2y plus 0. So value of y is 0. So we have one pair, that is x is equal to minus 3 and y equal to 0. So our stationary point is that is minus 3 and 0. So this is step 1. Now for step 2. As per the rule, here r is del square f by del x square. So the second derivative of del f by del x. Here this one is the first derivative. Del f by del x is 2x plus 6. Now the second derivative, that is 2x plus 6 derivative is 2. So here del square f by del x square is 2. Now s, that is del square f by del x del y. So either we get the derivative of del f by del x with respect to y, or the derivative of del f by del y with respect to x. Both answer will be the same. So the derivative of del f by del y with respect to x, that is 0, because there is no x in the del f by del y. Similarly, there is no y in del f by del x. So second derivative is 0. So the value of s is 0. And t, that is del square f by del y square, that is the second derivative of del f by del y with respect to y again, and the answer is t. So these are the answer of r, s and t. Now for the last step, that is step 3. As per the step 3, we have to find the value of rt minus s square. And value of rt minus s square, here r is 2, t is 2, s is 0. So final answer is 4, which is greater than 0. So here rt minus s square is 4, which is greater than 0. So we have to check the value of r. Here r is 2, which is also greater than 0. It means f of xy is minimum at minus 3, 0, and minimum value is minimum at minus 3 comma 0, and minimum value is f of minimum value is here. See, what is our main function? Our main function is x square plus y square plus 6x plus 12. So that is x square plus y square plus 6x plus 12. So substitute minus 3 in the place of x and 0 in the place of y. So here 9 plus 0 plus 6 into minus 3 plus 12. So 12 plus 9, that is 21, minus 18. So the final answer is 3. Let's move with one more example, and that is example 2. Find the extreme values of the function. The given function f of x y is, this is x cube plus y cube minus 3x minus 12y plus 20. So let's start the solution. Here given function f of xy is x cube plus y cube minus 3x minus 12y plus 20. So as per the rule, our step 1, and step 1 is for extreme values, that is del f by del x is equal to 0. So the derivative of f with respect to x equal to 0, that is here 3x square minus 3 equal to 0. So if I get 3 common, so x square minus 1 equal to 0. So value of x is plus or minus 1. And similarly, del f by del y equal to 0. So the derivative of f with respect to y, that is 3y square minus 12 equal to 0. If I get 3 common, then I have y square minus 4 equal to 0. So the value of y is plus or minus 2. So I have total 4 stationary points because I have 2 points for x and 2 points for y. So stationary points are for x equal to 1, y equal to 2. For x equal to 1, y equal to minus 2. Similarly, for x equal to minus 1, y equal to 2. And for x equal to minus 1, y equal to minus 2. Okay, so total 4 possibilities are there, 4 points are there. Now move for the step 2, and that is we have to find r, that is del square f by del x square. It means the second derivative of f with respect to x, and that is here the second derivative is 6x equal to 6x, just the derivative of 3 is 0. So here 6x. Now s, that is del square f by del x del y. So there is no y in del f by del x, and there is no x in del f by del y. So the value of s is 0 again. And t, that is del square f by del y square. So the second derivative of del f by del y, that is 6y. So here 6y. Now we move for the step 3, and that is step 3. We have total 4 stationary points, and these stationary points are 1, 2, 1, minus 2, minus 1, 2, and minus 1, minus 2. So these are my stationary points, and for these stationary points I will find r, s and t. Then I substitute this value in the formula rt minus s square, and then the conclusion, right? So for the first point 1, 2, value of r is 6. Okay, value of s is 0, and value of t, that is 12. So rst, so we have to substitute this value in the formula rt minus s square. So I get 72, which is positive, which is greater than 0, and here r also greater than 0. It means this point is minimum. Similarly, for the extreme points 1 and minus 2, my r is 6, s is 0, and t is minus 12. So RT minus S square, which is minus 72, which is less than 0. So neither maximum nor minimum, we can say it is saddle point, right? For the point minus 1, minus 2, here R is minus 6, S is 0 and T is 12. So again my RT minus S square value is minus 72, which is less than 0. So this point is known as saddle point. And for the last point, minus 1, minus 2, a value of R, that is minus 6, S is 0 and T is minus 12. So again get positive 72, which is greater than 0. So the given point is RT minus S square is greater than 0. But here R, which is less than 0, which is minus 6. So my given point is maximum. So here we have total 4 stationary points. These 4 points, the one point is minimum and one point is maximum. So we'll find the minimum and maximum value. So hence f of xy is maximum at minus 1, minus 2 and minimum at 1, 2. So the maximum value f of maximum at here what is our given function, x cube plus y cube minus 3x minus 12y plus 20. So here x cube plus y cube minus 3x plus 12y plus minus 12y plus 20, right? So here minus 12y plus 20. So I am substituting the value, that is minus 1 cube, here plus minus 2 cube, 3 minus 1, 12 into minus 2 plus 20, and after simplification the answer is 38. Similarly, f for minimum, that is 1 cube, here is 2 cube, minus 3, this one is 1, 12, value of y is 2 plus 20. And after simplification, final answer is 2. So students, this is the rule for finding the extreme values for any given function. We have to follow total 3 steps. In first steps, we have to follow the derivative of f with respect to x and the derivative of f with respect to y equal to 0. And after solving these two equations, we get the value of x and y. Then after we have to obtain the values of r, s and t, where r is the second derivative of f with respect to x, s is the first derivative with respect to y and the second with respect to x, or the first derivative with respect to x and the second derivative with respect to y. And for t, we have to the second derivative of f with respect to y. And in the last step, if we have RT minus S square greater than 0 for particular stationary points and R is less than 0, then we get the maximum point. If RT minus S square greater than 0 and R greater than 0, then we have the minimum point. If RT minus S square is less than 0, then neither maximum nor minimum point. It means that point is known as saddle point. And the last, RT minus S square equal to 0, then no conclusion is there. Further investigation is required. Please keep in mind this point. This is the most important point for finding the extreme values. Feel free to contact me for any query. Till that, enjoy the study. Thank you.